In our final example of ellipses, we're working backwards. So now we have some information about the graph of an ellipse. We have some information about the features. So we know that the vertices are at plus or minus 7, 0, and the foci are at plus or minus 5, 0. And so from that given information, we want to piece together the equation of this ellipse. So the first thing I'd recommend doing in this circumstance is plotting out these points to start to get a sense as to which way this ellipse is oriented. We can then determine what the center is and what the relevant constants in the equation are to be able to get that equation. So we give ourselves a coordinate plane here. So our vertices are at 7 and at -7. So we're about 7 units in each direction there. So those are our vertices. So that already tells us a little bit, as I'll get to in just a second. But we'll also at the same time plot our foci, which are at plus or minus 5. So I'm going to go 5 units to the right and to the left. And so those are our two foci. So first of all, we can see that our ellipse is stretched in the horizontal direction because the vertices are the farthest distance that our ellipse extends. So I know my equation is going to be x minus h squared over a squared, since the ellipse is stretched horizontally, the bigger denominator is going to be underneath the x, plus y minus k squared over b squared equals 1. So I know that's the equation that I'm trying to fill in. So the things I need to figure out are h and k, which are the coordinates of the center. I need to know what a is, and I need to know what b is. So a lot of that information is already given to me, or I can infer it from what we've done just with the graph that we sketched out so far. Hopefully it's obvious that the center of this ellipse has to be at the origin, because it's at the center. It's going to be halfway in between the vertices. It's going to be halfway in between the foci. So that point is halfway in between all of those. So our center, HK, is 0, 0. So that means in our equation, as we start to fill in this information, it's just going to be x squared in the numerator and y squared in the numerator. So we've got that much filled in. The h and k are 0 and 0. We also know what a is, because remember, a is that distance from the center to the vertices. So that's 7. We're extending 7 to the left and 7 to the right. So if a equals 7, then that means a squared is going to be 49. So then the last thing we have to figure out is what b is. Now be careful, b is not this distance here from the center to the foci. That is c. So we know that c is 5 units. That's the same in both directions. So we don't know what b is yet, but we do know a and c, and hopefully we remember that the relationship is a squared minus b squared equals c squared. So if I plug in a is 7, I get 49 minus b squared equals c squared is going to be 25. So now if I add b squared to both sides and at the same time subtract 25 from both sides, so I've got b squared is equal to 49 minus 25, or 24. And I don't even need to figure out what b is. I just need to know what b squared equals, since that's what goes into the equation, so I can fill that in right here. And so now I have the equation of the ellipse that has these features, the vertices at plus or minus 7, 0, and the foci at plus or minus 5, 0. So our first task is to figure out, to kind of plot out that information, get a sense as to the orientation of our ellipse so that we can write down the equation, and then we can start to fill in the gaps. The h and k determine where the center is, and then figure out what those a squared and b squared values are, either directly from the given information or using that a squared minus b squared equals c squared equation to help figure out one or the other.